Homework 8, problem 2. Find the real amplitude A3 and the phase delta 3 for some complex wave F3, where A3 is the complex amplitude, and we relate, of course, the complex amplitude is equal to the real amplitude exponential of imaginary times the phase, like that. Now, we're going to say that F3 is the sum of two other waves with complex amplitude A1 and A2 and has the same kx minus omega t factor. So if we state that F3 complex is equal to F1 complex plus F2 complex, obviously I can factor out this exponential, and this just says that A3 is equal to A1 complex plus A2 complex. And now we have to figure out how to find the different the real components A3 and delta 3 in terms of the real components A1 delta 1 and A2 delta 2. This isn't too bad. I think the easiest part is just to write it out by hand. And so this is, so first write this in complex notation. A3 exponential I delta 3 is equal to A1 exponential I delta 1 plus A2 exponential I delta 2. Now, in order to actually solve for these, though, it's better to write the real and imaginary parts. And so I'll do the imaginary first. A3 times the sine of delta 3 is equal to A1 times the sine of delta 1 plus A2 times the sine of delta 2, and A3 cosine of delta 3 is of course equal to A1 sine of delta 1 plus A2 sine of delta 2. In order to solve for delta 3, I'm just going to take the ratios of these two. That's going to get rid of the A1 and the A3, and that's going to give me that the tangent of delta 3 is equal to this ratio A1 sine delta 1 plus A2 sine delta 2 divided by A1 cosine delta 1 plus A2 cosine delta 2. So that's the first part. We already solved that. Now, to do the next part, what we could do is we could square each of these, add them together. We get A3 squared on the left-hand side, and we just have to go use some trig identities. If I don't want to do that, I can actually do something that's kind of fun, right? I can look at this in terms of vectors in the complex plane. And so let's treat A3 as green, A1 as red, and A2 as blue. And now I'm going to draw something in the complex plane, and so here will be the complex plane. Okay. And then I'm going to draw my A1 vector, and so it has length A1 and it has angle delta 1. And then starting from the tail of that, I'm going to draw my A2 vector. So this is A2, and this is delta 2. And the resultant, of course, if I add the two together, is this guy here, and this is A3. And this measurement here is delta 3. Now, if I go and I combine everything together, I can just use the law of cosines, and I can immediately write down that A3 squared is equal to A1 squared plus A2 squared. And then I want this angle right here, and this angle right here is going to be this angle minus that angle, and so this will be plus 2 A1 A2 cosine or delta 1 minus delta 2. And so I could just use the law of cosine to do this. So that's the simpler way. You can do it the long way. You get the exact same expression, but there you have to know some trig identities. This way you just need to know the law of cosines. So, yay.